syllabus or not? Are you getting my point?
Yes.
Conditional probability is in your syllabus, correct?
Yeah.
Okay. So you must know, yeah. So can you revise little bit from your Google or Chat GPT? What's the conditional probability? Then I will discuss. So tell me how we, first of all, in case of
It's
conditional probability,
basically like it's like there's different kinds of conditional probabilities. There's
yeah.
like the probability of a single event, the probability of the joint probability of two events.
So what's the
There's
condition? Wait. So what's the condition in joint probability events?
union. Is it union or
No, that is not the
intersection?
condition. The conditional pro okay, can you tell me how we represent the conditional probability, how we represent mathematically
It says it is mathematically denoted as probability of A with a line
A ob
over B.
yeah B. What does it mean? Suppose someone is asking probability of A oblique B, what does it mean?
Wait, can you repeat that?
Suppose someone is saying find P probability of A oblique B. What does it mean?
Find the probability of A like when B has already happened.
Yeah, probability of A when B is already happened.
Given.
Any doubt?
No.
So now, do you know how? Okay, before this, you should know. I think you must know this. Uh, there are two broad categories of conditional probability. You know this? One is called simple conditional probability, simple conditional probability, and the second one is called reverse conditional probability. Have you heard these words? Reverse conditional probability, or this is called as Bayes theorem. Have you heard these things?
No.
Okay, so let me introduce. So what's the simple conditional probability is? Simple conditional probability is a situation in which, okay, let us take some example first. Suppose there is a deck of 52 cards, right? There is a deck of 52 cards, and there are two friends, A and B. There are two friends, A and B.
Yeah.
Now, suppose what is happening? First, B goes to this and he draws any one card and he keep it to himself and go on, right? He draw one cards and keep it self, right? So one card drawn and don't replaced, correct?
Yeah.
Now after this, A is going to draw a card, right? Right? So A is going to draw a card. Now I'm asking, what is the probability that A will get an ace when it is given that B has drawn ace. B has drawn ace also. Are you getting it? So what is the main thing here? What is the main point here is we are going to find the probability of final event. Who is going at the end? Who is going to draw at the end? Which event is happening at the end? So A is going to draw the card at the last, at the end. And we are finding the probability for A. So this is a simple conditional probability, right? So it means all the previous events are given here or their probability are given. Now see this reverse situation. I'm telling you that, see, first B goes and second A goes. Now suppose I'm giving you the final event. See, my initial event, or we can say previous event, is card drawn by B. Card drawn by B. My final event, who is going at the end? My final event is card drawn by A. Correct? Now imagine this situation. This time I'm giving you that the finally A got an ace. What I'm giving you? I'm giving you the final event I'm giving you that finally A got an ace. Find the probability, find the probability that B had also drawn an ace. So what's the basic difference? So in the second case, basically final event is given and we have to find the probability of any of the previous event. Whereas in the simple conditional probability, initial events or previous events will be given and you have to find the probability for the final event. In the receipt, that's why the name is reverse. We are going in reverse. So final event is given, the final event is given here, and we have to find the probability of any of the previous event, anyone. Are you getting this basic difference?
The probability that B had also gotten an ace is like obviously gonna be 4/52.
Who who told you to solve this question? Do you know these things? You know these things? No,
Yeah, kind of, but I
kind of.
don't know them by the name.
No,
I
no.
might know the concept, but not
Kind
the
of
name.
means you are trying. Have you gone through the theory of these things? There are some special formulas, concept.
In school, my teacher just skipped the whole probability chapter. He just like we just did like a sub unit of probability.
That's why I was asking in the beginning, what's your syllabus is? I don't know what's your syllabus,
No,
what
my
is the name.
syllabus is all of this. My syllabus, I've sent you my syllabus. You have it.
So if all of these are in your syllabus, so we have to discuss these things in detail. These all are the, these all have the separate theories.
Okay. Combined events, mutually exclusive events, experimental probability, conditional probability, independent events and tree diagrams, Venn diagrams, set
See,
notation.
most probably, I'm telling you, most probably in your conditional probability questions, you will encounter this simple conditional probability only. Most probably. Because this reverse conditional probability will be for AS and A level, right? But simple conditional probability is from year 10 and year 11 continue, year 10 and year 11, yeah. So, so first analyze this question. This question is for simple conditional probability or reverse conditional probability. First of all, you have to decide this thing. And the formula is for probability of A when B is already happened is probability of A into probability of A intersection B upon probability of B. Have you heard this formula?
Nope.
Search it on the Google. Probability of
Yeah,
A
it
oblique
showed
B.
this on the Google. Yeah. It gave a real world example. It says if you want to find the probability that your train is delayed, given train is delayed, which is A, given that it is raining, B, the
Mhm.
probability of rain is equal to zero point 0.2. The probability of rain and delay is zero point 0.1. So, okay, 0. Okay, wait. Yeah.
First of all, please check that is this question
Wait,
is,
reverse conditional probability has a different formula. That is P
yeah,
A over B
I know
times.
this. Wait, don't get, mixture. Let us
Yeah,
proceed
this is
in
simple. The one
separate
that you just
case,
showed. Oh,
right? I told you that first we have to discuss this one. This will be most probably your question, right? So first of all, decide it. Suppose you're not, you don't have the formula for reverse conditional probability. No problem. First, decide it. Is it simple conditional probability question or reverse conditional probability question? Then we will see. Okay. So can you decide? Is it simple conditional probability or reverse conditional probability?
the bias coin is flipped and a ball is randomly selected. Find the probability that the ball is red. Wait, can you go to your diagrams again for the thing?
This is in front of you. Tell me what you want.
No, 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 the one where you do the reverse and the. I would say this is simple, maybe.
Simple?
I think this is simple.
No, no. You have to be confident, not just guessing, or I have given you that you will get the question of simple conditional probability, then you are guessing for simple conditional probability. Let
No,
me explain.
because the probability of like the dies
Wait,
is already
wait,
given.
wait, wait. First of all, please
The
see, there are two events.
probability of flipping,
Wait,
yeah, the probability of flipping the side of the coin is already given. You
wait,
need to find
Akansh.
the
There are two events. First, coin flipping. This is the first incident. This is the first incident that is the flipping the coin. And in the second event, you are getting some balls, right? Correct. Now see what is given. A biased coin is flipped and a ball is randomly selected. Okay, first one you have done, right? The second one. Given that, what's given? The
no, no,
red.
no. You said that my first one was wrong.
Okay, so first one. The biased coin is flipped and the ball is randomly selected. Find the probability that the ball is red. So you have to find the probability of final event or previous event. Let's see.
Final event.
Final event. So we have to find the probability of final event. So which theory will be applicable here? The first one, the simple conditional probability.
Simple,
So
simple.
you should write, wait, if you don't follow my steps, 99% you will do a mistake. This is not for this question only. I'm telling you the general method for all questions based on simple conditional or reverse conditional. But I know you will ignore this method. But my task is to warn you. Otherwise, your choice. Okay. So first of all, what we should write? Write the some some data that okay, what is your final event? So final event, I should always assume my final event as A, right? So final event. What's the final event? Final event is ball is red, right? What is the previous event? So previous event, that is the B, is the coin is flipped and the ball is randomly selected. No, no. First one, your first answer, where is the condition? There is no condition here. What's the condition here? What's the condition here? Yes, Akansh. This is the normal process. The first coin is tossed and Then you have to select the ball, find the probability that the ball. What is the condition here? Tell me. What's the condition you are getting here? If you are
Like
getting any
the
condition, yeah, tell
the
me, tell me.
condition is like the ball has to be red.
That's the final event. You have to find the no. What's the condition? That is the target. Your probability of finding the red one is any condition dependent?
I mean, it's dependent on the coins. No, no, yeah.
You have to simply follow your tree diagram. This is also conditional, but the tree diagram can give you this answer. What's the answer you are getting?
68 over 105.
Yeah, so that's
I
correct.
did
I
one.
told you.
Oh, I thought you said it was wrong.
No, I told you this is the correct.
Okay.
See this one. Given that is the condition. Someone is
Given
saying
that
that
the red ball is selected, find the probability the bias coin showed
head.
head. Wait. Given that the red ball is selected, so now we've seen our final event. Your initial event was the coin flipping.
Yeah.
Find the probability the bias coin showed heads.
Hmm. Are you getting?
Wait, just give me 1 minute.
Mhm.
Given that red ball is selected, find the-
So first of all, you have to decide this is a question of simple probability or reverse probability, reverse condition.
this is like, wait. So simple probability is when I've been given the initial event and I want to find the final. Reverse is, yeah, this might be reverse probability because I've been given my final event and I want my initial.
So this is your reverse conditional probability question.
Okay.
Now I have to give you the formula for reverse conditional. So probability of A when B is already happened. In this, A is your final event. Make sure that A is your final event. A1, A2, A3, A4, and so on. AN will all will your previous events. There may be multiple previous events, right? So they all are multiple previous events. Is it okay? So
Okay.
final event will be given. I am writing here. The final event will be given, and we have to find the probability of any one of the previous event. It can be for anyone. Like I can find for A3, A4, right? So what I'm telling you, final event will always be represented by A. Final event will always be, it's my suggestion, not the compulsory thing. I will recommend that final event should also be should be represented by A, and the previous event for which we have to find the probability. I'm repeating, the previous event for which we have to find the probability should be assumed as A1. So let me write what I should write A1. A1 is the previous event whose probability has to be calculated. Probability has to be calculated, right? So in this way, under this notation, my question will look like probability of A when A1 is already happened. No. It's wrong. We have to find the probability of A1, right? So it will look like probability of A1 when A is already happened.
Okay.
So it will be probability of A1 into probability of A when A1 is already happened upon. In this pattern, you have to follow this. So probability of A1 into probability of A when A1 is already happened plus probability of A2 now into probability of A when A2 is already happened plus so on. If you have multiple previous events, then you can continue
Wait,
this
but
pattern.
I don't have any of these probabilities.
Let me check. Why you are taking tension? Why you are moving one step ahead?
The
I am
probability.
I am concentrating my full potential to explain this formula. When I will solve it, then you will ask this formula. When I'm explaining this formula, you are attempting to solve it. That's the mismatching is going on. So during the mismatching, less power will be transferred. Please remember. See, Akant, I'm explaining you this formula. You are getting this first time, and you are showing your talent in solving this. When I will solve this, you will ask this formula. So how it is, what it is, why you are doing this thing, you will lose your potential always. Make sure. Don't ignore my suggestions and observations. See, you are getting this formula first time. So in place of understanding this, you are trying to solve it one step ahead. Useless. Have you understood this formula? What's the pattern is? What's A1, A? Have you understood
Yeah,
it?
so A1 is the previous event and A is the final event. So
Okay.
we've been
A1 is
given the
that previous event
probability
whose
of,
probability has to be calculated. So what is, okay, let
yes,
us
I
write it.
know the
So what is the
probability
A1?
of
Write all the events now. Write all the events. Write it. So A1
A1
is
is the
what?
previous event, which was the coin rolling in a heads,
Yeah. So coin shows
while
head.
while
Write it.
A
Write
is the ball being
coin
red.
shows head. So what should be A2? Other previous
A
event will be coin shows tail. There will be only two options. Now, so what should be these
another
probability?
previous event. When you
Sorry,
flip the coin, you either get a heads or tail. There's no previous event before that. Or you mean like as they go, you keep eliminating the
same
events?
thing I was saying. Yes. If previous event, what will be the previous event? Previous either you will have head, either you will have tail. Well, see, if you see like this way, then flipping a coin is an experiment. This is not an event. I'm getting my point.
Yeah.
Flipping a coin is an experiment. This is not an event. Any doubt?
No.
So the one initial event is showing head. So other will be tail, obviously. So now we have to find what are these probability we have given. See, the head probability is 2 by 3. So you should write the head probability is 2 by 3. That's 1 by 3. Given now the probability of A when A1 is already happened. What is A when A1 is already happened? It means if
The
you have,
A is the ball being red.
yeah. So now A1 is already happened. It means A1 is what? You have had already. So you got
So four
here
seven seven.
and this. Yeah, 4 by 7. Correct. So this will be 4 by 7. Similarly, probability of A when A2 is already happened. It means if you are going from the tail and red, it is 4 by 5. Correct? Now tell me which probability is not given. You were saying me that some these are not given. Where these are not given? All these are given. Yes?
Okay.
Please find it.
So you have four fifth. So wait. A1, right? So 2/3 times by 4/5. And I think I have to do it again, right?
Mhm.
times by probability. Wait. Oh, okay, I'll just divide it. Okay. 8 over 15, right? Divided by probability of A1, which is um 2/3 times by 4/7. Wait. Okay, A1, which is 2/3 times by. Okay, this will be 8 over 21. 2/3. Wait. 2/3 times by 4/7 times by 1/3 times by. Getting 15 over 4.
15 over 4. Okay. If your calculation is correct, then okay. Any doubt?
Um,
If you check 2 over 3 times 20 of 8.
how can probability be more than 1 though?
What you are getting?
15 over 4.
Check your calculation.
I did 2/3 times 4/7. That's 8 over 21. Thirds 4/7. Oh, it's plus. Oh, yeah, 2/3. Okay, wait. 8 over 21. 1/3 times 4/5 plus 8 over 21. Okay, yeah. 8 over 21 divided. Wait, no. Oh, 8 over 21 plus 1/3 times by 4/5. 68, so 8 over 21. 10 over 17, yeah.
10 over 17.
Yeah.
Correct. So have you understood it? And
Okay.
let me show you one conceptual drawback from the solution point of view. See, I am sharing you the working of this uh, marking scheme. See, they have done it from the, simple conditional quality, right? See, but this is not the correct way. I'm telling you, this is a matter of luck. They got this, but this is the method to solve for the condition for the
Can
reverse
I,
conditional.
just pause it here so I can write down?
Yeah.
I'll just write simple conditional probability.
Mhm.
Wait, can you go up because this isn't the normal formula? Yeah, okay. P of A times by P of A. Yeah, now can you go down? Reverse conditional probability. Now I want to see the reverse conditional probability. Okay, wait, in this, right, I have a question. Will you always have A1 and A2, or can you only have like, is it possible to have only A1?
No, no. We will have. If only one event will be there, then this will be not any condition. What's the condition? They can ask, given that the red ball is selected, find the then see, suppose you are saying that in place of there are two options, head and tail, if there is only one option. So find the probability that
Yeah.
this is head only. So that the probability will be one. What's the problem? If there is only one path, suppose this tail is not present here. This tail is not present here, right? Suppose this tail is not present here, and you are telling me find the probability I'm getting red, find the probability that it is coming from head. So all
Okay.
the parts are coming from head only because this is the only path. So obviously the probability will be one there. Are you getting my
Okay.
point?
Okay.
Any other doubt?
Just 1 second. Times by. Okay, wait. So the probability of A over A1 is the probability of A occurring when you already have A1.
Yes. That's why I was saying that you should write all the terms like what is A1, what is A2, what is your A. You make sure that you have written this before attempting to solve reverse conditional questions. Otherwise, you will get confused.
Yeah, my teacher never taught me any of this.
You can search it on the Google. This is a standard theory, reverse conditional theory. It is also known as Bayes theorem. See, Bayes theorem, you can search it on the Google. You will get this Bayes theorem. Okay. Let me give you another question. This one. Uh, till Joule level, these tree diagram, conditional probabilities are good one.
Okay, I'm done.
Please see.
A bag contains, okay. Two marbles are selected at random without replacement. A bag contains seven blue and five red. Complete the tree diagram below. The bag has 5 over 12 thread. So 7 over. Why does it say 7? Okay, oh yeah. So blue would be blue would be 6 over 11.
Correct?
Red would be a same 5 over 11.
Hmm. Correct.
This would be, oh well, then that's just the add, okay, 4 over 11.
Hmm. Correct. This one.
Find the
Find the probability.
probability that exactly one of the selected marbles is blue. So, um, the probability that they're both not blue is 512 times 4/11th, right? So 512 times by 4/11th, 1 minus answer. Oh, find the probably the exactly one of the selected marbles. Okay, so wait, hold on, just 1 second.
Mhm.
5/12 times 4/11 plus probably of getting two blues, so 7/12 times 6/11. All right, so 5/12 times 4/11 gives you 5/33. 7/12 times by 6/11 gives you 7/22 plus 5/33. One minus answer, so 35/66.
Correct.
That's what I'm getting.
So, in all probabilities question, please read the question carefully. Exactly, at least, at most. These are the very important keywords. This one.
Two events are such that the probability of A's complements and wait, what is that? Is that
Union.
union?
Yeah, union.
So union are the terms in both. Okay. So the probability in A's complement union B's complement is find. Oh, okay. So that is finding the probability. Wait, what? Find probability of what? Like A when B is given? What is that?
So, set theory is in your syllabus, right or wrong?
Let me read off. Let me read. It says set notation.
Set notation, it means yes, this is in your syllabus. So, set notation is in your syllabus, probability is in your syllabus. So, the combined question can also be asked.
Okay, can you explain me set notation? Because my teacher barely taught me probability. Let me just search up what set notation is. Set notation. Oh, well, the union stuff, that is set notation. Okay.
Okay, should I
So,
discuss?
yeah, wait, this line, right? You said it was the conditional probability looks like this,
Yeah,
right?
conditional probability. For the simple conditional
Yeah, but
probability,
how do you know it's simple?
wait. On the Venn diagram, first of all, please shade this region. How you will shade this region? A complement,
So
union B
the
complement.
elements that are not in A and the elements that are not in B is everything outside the Venn diagram.
So see, for this, we can do in this manner.
Yeah,
A
it's everything outside the two circles.
this is basically this. Yeah, correct. This. So this is the reason. Let me shade it.
Why'd you include A?
Why not?
You said all of the elements in A's complement and in B's complement.
Okay. Let me explain it.
Wait, what? Why'd you circle B?
Let me explain it. So basically, there is a De Morgan's law. If, see, this is your expression and you want to analyze it, you are unable to think. So if you do the two times complement, suppose this is your expression Z. So Z will be equals to. Now this complement can be distributed. So it will be a complement, and this union becomes intersection. This becomes complement, and the last complement will be as it is. So the
What do you
complement
mean
and,
complement?
sorry,
What do you mean complement?
this is a method. This is the De Morgan's law. Basically, I'm
Okay, wait.
explaining it. So see,
I
this
don't
is a
understand why you added one. Why did you add one? Like,
this is the
is it just
method.
part of the law that you add complement?
See, suppose this is the event A or this is the set A. If you take complement of complement, you will get again A. Am I right? There will no change.
Okay.
So now the rule says if you distribute this complement, so this distributed to this one also, and this one also. So the complement, see this twice complement, this union becomes intersection. This B has also two times complement, and this is your left complement. So the this will be complement of complement becomes A intersection. This is B, and you have this complement left. So this is very simple to analyze now. See how we can analyze it simply now. So this is your A, this is your B. So we are interested in reason. See A intersection B. Where is A intersection B? This is the A intersection B, right? This is your A intersection B. But I have to shade complement. It means all region except this. So what I will do, I will include all these except this A intersection B. So that's why I have shared
Wait, wait, wait,
that
wait. Explain the last part again. I thought now because of the De Morgan's law, you only shade the middle.
this is A intersection B. De Morgan's law is
Yeah.
this one.
So you manipulated the first one to show that it's A intersection B. So I thought you only shade that.
A intersection B is this, right?
Yeah.
And you have one complement left here. See, what is the meaning? So see, wait, you are confused
What do
here.
you mean
Suppose,
one complement left? You mean that big line is a complement as well?
yeah, I have given two compliments. See here, this is the first compliment and this is the second compliment. I have written
No,
here.
you wrote A complement complement intersection B
Wait,
complement
wait, wait,
complement.
wait, wait. Fundamentals are missing. That's why this is happening. See, basically, see, suppose this is the event A, this is the universe. So this is the A, and if you want to shed it, you will shed it like this. Correct? Now
Yeah.
I have to shade A complement. Where is my A complement? Can you tell me? Where is my A complement? How I can shed it? Is it possible to
Everything
shed it?
outside of
Yeah,
A.
this one. So you are getting the complement meaning, right?
Yeah.
Now, what's the De Morgan's law? De Morgan's law, there are three rules. So one of the law is, suppose you have this event A, if you apply two complements, negative of negative becomes positive. So complement of complement becomes the same thing A, right? Basically, you have the
Oh,
event A and you are doing twice complement.
yeah. You're
No,
basically trying to say that anything that is not in A's complement is A.
yeah. Negative of negative becomes positive. False of false becomes true. So now, see, I have to analyze this A complement union B complement. See, as I have told you many times, the 3 raised to power minus 2, what does it mean? Can you tell me the value of 3 raised to power minus 2?
3 raised to the power 1 over 3 to the power 2, 1/9.
Yeah. I have told you that negative power human mind cannot understand, right? Similarly, with complemented variables, logical thinking is difficult for human mind. Please see this. With complemented variables, very difficult to analyze in reverse manner, right? For example, I can give you one more example. For example, in positive sense, if someone is saying bread or butter, right? Or see, someone is saying, I like uh, bread or pizza, right? If someone is saying he likes bread or pizza, so what does it mean? He have options that either he can eat bread or pizza or both, optional. But if someone is saying, I don't like bread or pizza. What does it mean? See, here it has or, but this is giving you the and condition. If I'm saying that I don't like bread or pizza, what does it mean? I will not eat even bread and pizza also. I have written this or, but this is giving me the feeling of and. Why? Because this is the negative sense. Are you getting this logic?
Yeah.
So in the positive, it is simple. Bread or pizza, if you have or, it is giving you the meaning of or. But in negative sentences, this or is giving you the feeling of and will give you the feeling of or. So it means in the complicated logical discussion. So what's the conclusion is, as human mind cannot understand this negative power, cannot understand this negative sentences logically. So similarly, the Venn diagram with the complemented variables is difficult to analyze. So what I will try to do, I will try to make it with the positive literals, positive variables. So for that, I will use the De Morgan's law. So what I will do, whatever this is, whatever. If I write
Wait, so
two,
can I use De Morgan's law for like the opposite, like A complement intersection B complement? Can I use
yeah,
those?
yeah, obviously. This is the law. This is not a
And then
specific,
the intersection would switch to a
yeah,
union.
obviously. So see, this is the same thing. If you do the twice complement, so still this is A complement union B complement. Am I right? No change. But you will apply this. Now you will solve this. So this first complement will apply to this one also, and this one also. So what it will give you, A complement complement. This union becomes intersection complement complement, and
And there's
one
still
more
one complement left.
left. So this complement A becomes
So
A
you add
in,
two complements.
yeah. So are you getting this left? This is equivalently, this is logically same as this one. They are logically same thing. Now, since this is positive variables, so it is easy to analyze now. How it can be analyzed? This is your A, this is your B. So A intersection B is this middle one, and we have to shade the complement of this. It means all the regions except this. So I will use this one. Are you getting Akansh? This is so much
Yeah.
conceptual things.
Okay. So I have one more question. Is probability of A union B, can you write this? A union B, the bracket, and put the complement outside. Put the complement, yeah, is that the same as like what we just discussed? Probability of A complement union B complement?
No. If you apply the complement here, this will be the probability of A complement intersection B complement. This one. This will give you the same this thing.
Oh. So when the complement is outside, my sign flips?
Sign means, see, this is the rule. Union will becomes intersection. Intersection will becomes union. Obviously.
The union becomes intersection when there's a complement.
Yeah, there is a complement. Yes.
When there are two complements, right?
Mm-hmm.
When both terms have complements, right?
Tell me any case.
Wait, so union will become intersection when both terms have complements, like A complement intersection B complement, or A complement union B complement. So,
No, no. If you have this one complement, then you will implement it. So it will implement it to this one also, this one also, this one also. This becomes complement complement. This intersection becomes union. This becomes complement and complement. So this becomes your A union B. You should go see, note this topic, De Morgan's law. Go through the some chat GPT, De Morgan's
okay.
law.
And wait, can you send me some questions on probability?
Okay, sure. I will send you. Any other thing?
No, I don't have any
Okay.
other doubt.
Okay, okay. So I will send you the priority questions. Till then, revise all your remaining topics. Is it okay?
Okay.
Okay, Kanch.
Okay.
Thank you.